Hi, my name is Rhonda Howell. I'm an 8th grade math teacher at Weston High School in Jackson Parish. I am very passionate about trying to make every single one of my students feel like a success, regardless of their ability level. If they're doing their absolute best, we have to learn to celebrate those accomplishments, even if it's just a 70. The more we believe in them, the more they believe in themselves. The lesson we will be doing today comes from Open Up Resources Unit 4. We have been working on multi-step equations, which include distribution, combining like terms, and variables on both sides of the equation. The class I will be working with today is a group of 14 8th graders. Their ability ranges from level 4.2 to 8.9 on the Moby Max computer program placement test in math. We use this program as an RTI tool because it bridges the gaps in their previous learning and helps fill in those spaces where they fell behind. In the lesson today, we will be focusing on the mathematical practices of critiquing others' work and justifying your own responses. The students will be working in groups of 3 and will be given a problem that has been worked incorrectly. The students will have to analyze the problem in their groups and come up with a strategy to determine if the answer is correct or incorrect. Then as a group, they will solve the problem correctly. And to take it a step further, they will have to provide a written explanation of the steps that they have taken and what they have found. I do this to help them become stronger in their constructed response items on the LEAP test, and also to show them that it's very important to be able to write about each subject matter that you have. I am very excited to see how they do on this. It is a little bit harder than what we've been doing in the past, and it will give me a clear understanding of the foundation they have built on multi-step equations. Okay, today we are going to review some of our complex multi-step equations. Read the objectives for today for me, Cooper, real loud.
Students will identify mistakes made in a given problem and explain how to correctly solve the problem. Students will identify the number of solutions in a given problem and justify their reasoning.
Okay, so those are the things we're focusing on. We have been working multi-step equations for several weeks, okay? We've also done number of solutions. Today we're going to take this one a step further and make it a little more detailed and a little harder by having you look at someone else's work, which is one of our mathematical practices, and critique it and see what they did wrong or what they did right. Okay, your bell work problem that you just got finished working on. Will somebody read that for me very loudly? Charlie.
Megan worked the following problem and said that there are no solutions to this given problem. Was Megan correct in her answer? State why or why not. If she was not correct, work the problem out correctly and explain where her error lies. Okay, y'all have already been working on this in your groups. Did you think that Megan was correct in her answer? Raise your hand. Was her answer correct? Is this no solution?
No.
No. Okay, Elsie, what do you think the answer is?
I got -30 equals -20. So I don't think that could be a solution. So I had no solution.
Okay. Anybody else have something different? Kaylin, what'd you get?
5x minus 30 equals 5x minus 30. That's infinite solution.
Okay, why is that infinite solution?
Because it's the same on both sides.
Okay, so let's look. We have two different answers. One's no solution, one is infinite solutions. Did anybody else get something different? Okay, let's look. On this side, when we distribute, what do you get? What is 5 times x?
5x.
5x. What is 5 times -6?
30.
-30.
-30. On the right-hand side, what do we need to do first?
You need to add the x's.
Add the x's. Will we change the sign when we're adding those x's?
No.
Why?
Because they're on the same equal.
They're on the same side of the equal sign. When do we change the sign to the opposite?
When you go
When they're on opposite sides of the equal sign.
When we're going to the opposite side of the equal sign. So 2x plus 3x gives me what?
5x.
5x. And then, what can I do with -20 and -10? Combine them. They're like terms as well, right? So what is -20 plus -10?
-30.
-30. So on this side I have 5x minus 30. On that side I have 5x minus 30. We check our coefficients first. What's my coefficient of x on the left-hand side? How many x's did I have?
5.
5. What's my coefficient of x on the right-hand side?
5.
So they're exactly the same. Okay? That tells me that it's either going to be what? When the coefficient,
Infinite solution,
or?
no solution.
Very good. When our coefficients are exactly the same, it narrows it down. It gets rid of that one solution. Okay? Then we look at our constants. On the left-hand side, what's my constant? My number that stands alone. Negative 30. What's my constant on the other side?
Negative 30.
What do we know about them?
If they're equal, they can have an infinite number of solutions.
When they're equal, I have an infinite number of solutions. Okay? That means any number that I plug in for x will work. Good job. Any questions about that? No. Okay, we are going to move on to your next problem. Y'all will be working in groups. We're going to take someone's work and you're going to critique it. Now, critique doesn't mean criticize, okay? Critique means look at it. What did they do correctly? What did they do incorrectly? Okay? It's going to be a multi-step or a complex equation. What are some things that make you think a problem's complex? Difficult. A little bit harder.
Multiple components.
Multiple components. What else?
Parentheses.
Parentheses. Fractions. Anything else?
Negatives.
Negatives. Okay. So we're going to have all of those things in this multi-step problem. Okay? When we are solving a multi-step problem, think back to the anchor chart y'all put in your notebook. What's the first thing we do in a multi-step problem? Check for what?
Get rid of the parentheses.
Get rid of the parentheses. Okay? What if it doesn't have a parenthesis?
Then you just skip that step.
Skip that step and move on. Okay, what do we do after we check for parentheses?
Combine like terms.
Combine like terms. On the same side of the equal sign. Somebody from this table, if it's on the same side of the equal sign, remind us. Do we change our signs or do we not?
We change it.
If it's on the same side of the equal sign,
We don't change it.
you don't change it. When do we change it?
When it's to the other side of the equal sign,
When we're jumping to the other side of the equal sign, what do I do to the signs?
we change it.
To the what?
Opposite.
To the opposite. Very good. So when we're combining like terms, we're looking for like terms on the same side of the equal sign. So we're not going to be changing those signs. Okay? After we've combined our like terms, what do we do next?
Move the variables to one side.
Move the variables to one side. Okay? Will there always be a variable on both sides?
No.
If there's not, just skip it. How do I move the variables to one side? What do I do? We moved one of them. Which one did we say was easiest to move?
The smallest one.
The smallest one. How do I do that?
And
Add the opposite. Okay, very good. And after we do that, then we should have like a two-step equation. Okay? And then we just solve it like we normally would. Okay? So we went through the steps. Now, you're going to have to look at someone else's work and decide if their problem is correct. It's going to show all of their steps. What would be some strategies you could use to check their problem? What are some ways you could go about checking? You're not going to have a key in front of you like I do. What could you do to check the problem and see if it's correct? What are some things you could do?
Make sure they follow through all the steps.
Make sure they follow the steps correctly.
you could solve it yourself.
Okay, work it out and solve it yourself.
Use the checking method.
Use the checking method where we substitute their answer in for X and see if it works out. So all of those are different strategies that you can use to determine if their answer is right or wrong. So that's the first thing you're going to do as a group. You're going to look at this problem. You're going to determine what strategy y'all want to use to figure out the problem. When we finish, I want one paper turned in from the group. One paper, so y'all determine it, okay? After that, we're trying to prepare y'all to be a little bit deeper in our thinking of math. So you're going to have to explain in words on your paper what strategy you use to check the problem, okay? What did that person that worked the problem do correct? What did they do incorrect? And then how did you work it correctly, okay? What are some things I need to remember when doing an explanation in math?
Math words.
Use math vocabulary. If I'm in science, what kind of words do I want to use?
Science words.
History.
History words.
So math, people don't realize math vocabulary is important. That's a way to show the people checking your papers that you understand what you're doing. What else is important?
It explains how you solved it correctly.
Okay, it explains how you solved it correctly. You included all your steps. What else? Do y'all think neatness matters?
If it's not readable, you can't tell.
If it's not readable, I don't know if it's right or wrong, or whoever's looking at your paper. Also, what about the order you write things? When you're doing work on your own and you're doing scratch paper, do you do it in order? If you have scratch paper?
So you put it wherever.
Put it wherever. On this, would we need to just put it wherever? What would we need to do when we're writing out our steps and how we worked it?
Write it in order.
Write it in order. You want it to make sense. You want people to be able to follow what you did and not have to look around and guess, okay? On that constructive response of the standardized testing, you're doing it on the computer, but you still need to be logical in your ordering. They don't want to have to look around. Does that make sense? It is very important that each person in the group have a job. Everybody has to participate, okay? I need y'all to determine a leader. I need y'all to determine a recorder that's going to write the one you turn in. And I need y'all to have a timekeeper. Okay, so y'all get to determine that once we start. If your group has a question, turn on your light. I will come to you and help you. Okay? When you finish, turn on your light. But we're going to go ahead and look at this problem. Okay. Is this correct? Eli, read this for me.
Can your group determine if this problem was worked correctly or not? If not, word it correctly and then provide a detailed written explanation of what was done incorrectly in the original. Be prepared to share your strategy, explanation, and solution.
Okay, are there any questions about what you're expected to do? What's one thing you're expected to do?
See if that equation is correct.
See if the equation is correct. Okay, somebody else? What's another thing I'm expected to do?
Work it out correctly.
Work it out correctly. Somebody else? What's that? What else am I supposed to do?
Write an explanation.
Write an explanation. What does the word strategy mean?
Share how you solved it.
Share your steps, your process. Okay? Are there any questions? Okay, you may begin. Remember to pick a group. I will be coming around watching. I want to hear math talk. Okay? So everybody start coming up with your strategies. I should hear math talk. Reflecting back on today's lesson, I was very pleased with how it went. I feel like they met the objectives of being able to critique another student's work and find the errors in the solution to a multi-step equation problem. They also did a great job in working through determining the number of solutions in our bell work. There were a couple of people who got the bell work incorrect, but through the discussions, they straightened it out in their mind. I wasn't surprised by this because we had just covered that a day or two before and they haven't spent a lot of time on the bell work problem. After the video ended, the students continued to work in their groups on their strategies and solving the problem. Then the next hour that I had them, they shared their information with the class. I was very pleased in the strategies they used. I had one group who worked the problem out first themselves. Each person in the group worked it out, and then they compared answers, and then they compared their answer to the answer that was given in the slideshow. Another group decided to check and make sure the person had followed the steps correctly, and they were able to determine the error in the problem that way. And the last group worked through the problem as well. I had one group who did recognize the error, but then when they were solving the problem themselves, they made another error in computation, which caused their overall answer to be wrong, but their strategy and their observation of what was wrong in the original was correct. Something I would do to change this lesson and make it a little bit better, I think, is to provide the students with 3 different levels of responses. A really good one that includes all the details that you need to have, a mediocre one, and then one that's missing a lot of detail. I think by having the students look at different types of work from actual students and see how hard it is to grade information when it's not presented in a good format will help them be more conscientious when they're doing their work. Overall, I think that the majority of the class is ready to move on. The mistakes I saw in this group were more computation errors. They messed up on a sign. So I feel confident in moving on to our next step, which will be solving systems of equations.